Hi, kids. Time to extend the law of signs to the ambiguous case. So if you think about all our practice problems that you've done so far, once you learn the algorithm, you really are just plugging and chugging, right? So as long as you remember the ratio, which is a very easy ratio, right? As long as your angle is opposite your side, these ratios hold, and you're just looking to fill in your knowns and solve for an unknown, right? So from middle school geometry, and you remember how to think about triangles, kind of like when you did your proofs, right? You were proving triangles congruent. You had to look at your cases. So far, for us to solve a triangle with the law of sines, we have been non-right triangles. We have dealt with given one side that is included between two angles, or given two angles and the side is not included, right? Which of course can look like that as well. That's when we've used the law of sines. Well, what about when you are given two sides? So that's neither one of these cases. This is two angles. This is two angles. This is two angles. And one side, right? In each one of those cases. Well, what about when I give you two sides and the non-included angle, right? So this is what we've done so far. Today, the ambiguous case is when I give you two sides and an angle that is not in between them. Side, side, angle. And of course, if you read that backwards, you remember why you can't use this as a proof of congruency. There's some issues. And what it means is there's more than one triangle that can be created if I give you this information, right? Angle, side, angle, 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 side, or side, angle, angle, all stands for what are you given? I am given the lengths or the measures of two angles, and I'm given the length of one side. For both of these cases, I am given the measure of two angles and I'm given the measure of one side, but the one side is not included in between there. This time, I am given the length. I am given the length of two sides, and I'm given an angle that is not included. There's an issue. I can only make one triangle with this information. There's only one triangle I can physically construct with this information. And of course, these two really, again, are the same. But if you have two sides and an angle not included, you might be able to make one triangle. You might be able to make two triangles. You might also not be able to make a triangle at all. So let's see if we can get this together. Okay, so here's my cases so far. Side, not included, and two angles. Right, so that's two angles and a not included side. We cannot use the law of sines when you have two sides and the angle in between them, or no angle measure at all. We need the law of cosines. That's next. So of course, if I give you two angles, I can always use geometry and get the third one, right? I add these two together, and then this is 180 minus, and then I can have, right? I can get the other side using the law of sines. But if you are given two sides and a non-included angle, so there's an angle, there's a side, and there is a second side where The angle is not in between. It is not side angle side. So I'm going to give you some language that I use. If this is my angle, I call this side connected to the angle. Obviously, this side is connected too, but I want to use the connected up to the connects to the non-connected side. I'm going to call this the swing side. Because since this angle isn't fixed, this side can swing. I can try to bring it inside here and meet the third side, or I can go longer, right? We still use the law of sines, but we have to be very careful with it. So look at this picture. There's all my labels, right? My capitals for my angles, my lowercase for my sides, and everybody's opposite one another. There's me dropping the height from the top vertex, right? So I made a right angle. The height of my triangle is this formula. Now that comes from triangle trig, right? The minute I make a right triangle, right? This angle here, angle A, the sine of angle A is the opposite over the hypotenuse. Solve that for h and you get b times sine of this angle here. Okay, so that's the length of that green height, is b times sine of A. So it is important, as I said before, every time you recognize you have side-side angle, which again, read that backwards, you see what it is, you need to identify the non-included angle. So if I've given you B, B is connected to the non-included angle, and A is the swing. Because this angle isn't fixed, I can swing that angle around. So I have a bunch of different cases. Case 1, if the non-included angle is obtuse, right? And you remember obtuse means greater than 90, right? In case 1, if the non-included angle is obtuse, and if the swing side is longer than the connected side, so here's my situation. Here's my non-included angle. Here's the side that is connected. Here's the base. Where's my swing side? My swing side is going to be attached to C. If this swing side is longer than the connected side, there's only one triangle that I can make. Right? Now, I've labeled this C on purpose. Imagine this C is the center of a circle. And it's a radius because it goes out to the circumference. Imagine taking this yellow radius and swinging it, because this angle isn't fixed. Swinging it all the way around, how many times does it intersect my base? Once. One triangle is formed. Again, this is if the non-included angle is obtuse. Or what's the other case? If the swing side is smaller than the connected side, what happens? There's my non-included angle. Here's the connected side. Now I'm going to draw my swing side. This time I drew the swing side that was longer than. Now I draw a connected side that's shorter. Look at the circle I make with that radius. No matter where I how I change this angle, no matter where I swing this, how many times will the connected side meet the base? It won't. No triangle is formed in this case. So that's all case one. Case one, I just have to compare the swing side to the connected side. Swing side to the connected side. But what about case two? What if your non-included angle is acute, right? And remember, acute means you are less than 90 degrees. This time I have to not compare to the connected. I'm comparing the swing side to the height. Remember that green line that I drew? So this time, here's my non-included angle is less than 90 degrees. I was given this side, the connected side, and then I was given the length of the swing side. First, I'm going to draw in my height. If your swing side is less than your height, how many triangles can you make with those measurements? Remember, you're given the measurements of the non-included angle, the connected side, and the swing side. You can change this angle. Well, if this swing side is less than the height, you ain't gonna make a triangle. What if the swing side equals the height? Non-included, connected, and now let's do our swing side. My swing side is the same as my height. Well, what kind of triangle do I have then? Right? When you swing this radius all the way around, how many times is it going to hit the circle? It's only going to hit it once, and at what kind of angle, by the way? One right triangle formed. But what if not compared to the height? This time not compared to the height. Swing side compared again to the connected side. So here's my acute angle. Here's my non-included angle that is acute. Here's the length, the side that I was given that is connected. And now I'm going to draw my swing side. If my swing side is longer than the connected side or equal to it, there's my height, but I'm not comparing to my height. Here's the scenario where the swing side is equal to the connected side. How many triangles can I make? One. Right? Because certainly if you lay this on top of itself, there's no triangle. But you have what kind of triangle is that? Isosceles, right? Could be equilateral depending upon this length. But here's the kicker. If the swing side is smaller than the connected side, not equal to, because we've just done equal to, and the swing side is bigger than the height. There's my height. But the swing side is not as long as B, but it is bigger than height. What happens? That line, that side is bigger, is longer than my green height, but not as long as B. Take this height and swing it around your circle. It's going to intersect the base twice. OMG. This is our ambiguous case. So there's the first triangle, right? When my swing side 1. So I had this length. This length is fixed. It's given to me. But because its length is in between the height and the connected side, when I swing this around, because this angle isn't set, when I swing it around, it actually intersects the base twice. So it can make this triangle here. Notice that the angle that I get there is acute. But look at the second triangle. Do you see the second triangle there? That angle, trying to draw 3 arcs in there, is obtuse. So when you have this scenario, there's 2 triangles that can be formed, an ambiguous case, one where the other base angle is acute, and one where the other base angle is obtuse. Right? So the non-included angle was one of the base angles. And then this swing side is going to make another base angle. Because of the size of the swing side being in between the height and the connected side, there's 2 possibilities. You could have an acute base angle or an obtuse one to go with your non-included acute angle there. Remember, we always started in this case 2, we started with the non-included angle as acute. So if your non-included angle is obtuse, you don't have the ambiguous case. You only have the ambiguous case if the non-included angle is acute. So here's a nice applet that is attached to, linked to this PowerPoint that's online, as well as a video, right? You can click both of these to play around with these cases, right? Get a visual and try to get it sunk into your brain. So this question is asking you how many triangles. You don't have to solve a triangle. It just says how many triangles are possible satisfying the given conditions. So to answer these questions, I see what I did there. Each one of these is a side-side angle situation. Right? So for example, A is the non-included angle. B is connected. And then you've got your swing side, and your swing side is coming from here. and you're told that length is 12. So, oh, my drawing is poor because this is obtuse, right? Here's my swing side. And I'm told that that length is 12. Since that length is longer than the connected side, I'm going to be able to have one triangle. Didn't ask me to find it, just said how many. So my choices are 0 triangles, 1 triangle, 2 triangles, right? So that's how these questions are answered. And we'll do some more of those in our live session. But I want to get to the case where we're solving one. Oh, I just wanted to highlight the fact that of these two, I went to my obtuse ones first because I know my obtuse ones are either 1 triangle or no triangles. I'm not going to have my ambiguous case unless I have an acute angle. So acute, my given angle is acute. So it is only these where I'm possible to have the ambiguous case, and I need to find my height to be able to, right? If you're acute, you need to find your height. I don't care what I call A, right? I know I'm calling him different here, but whichever one, right? These are all the non-included angles. Okay, need the height. All right, so let's do this one. Solve the triangle. So let's set it up here. So I don't connect it on purpose, right? I drew an acute angle. It's called B. Opposite of B is 9. And C is 11. We are given side-side angle. So connected, swing, acute, find your height. The height is sine of this angle times the hypotenuse created by this right triangle. I got 9.9 out of that. 9.9, the height. Who are we comparing the height to? The height of 9.9, compare that to the swing side, right? Look at your notes. If the swing side, which is 9, compared to the height, is smaller, how many triangles are possible? Okay, that's not going to connect. It's too short, right? It's shorter than the height of 9.9. So this is, no matter where I swing this side of 9, it's not going to be able to intersect the base and create a triangle, no matter how long or short this is, right? It's never going to swing around and intersect it. Therefore, no triangle. But let's look at this one. Oops, sorry. Given triangle ABC, where B is acute, so I'm going to need to find the height. The connected side is 11. And here's the swing side. And the swing side is 8. So drop that height. Create your right triangle. Your height is 11 times sine of 35 this time. And I plugged that into my calculator and I got 6.3. And remember, I'm comparing the swing side, and the swing side was 8, which is greater than the height. And what's true if it's greater than? If it's greater than the height, I need to also compare it to the connected side. The swing side, though, is less than 11. The connected side. If your swing is between the height and the connected, you are going to have 2 possible triangles. So this is a lot of work. So let's set up the scenario where my first situation is that this angle over here, when I bring this, this is going to come down and meet, I'm going to be able to create a triangle like this, where the second base angle is acute. And then I'm also going to be able to swing it around and meet like this, where the second base angle is obtuse. So let's take care of the first one over here, right? What do I know? I have the sine of 35 compared to the length opposite it. And then I have, if I call this, right, this is little c, so this is angle C over here. So the sine of angle C compared to 11. I solve that, right? I get sine C by itself, and then I inverse sine. And I got C was equal to close to 52. So for the first triangle that is possible, I have 11, 35, 8, and 52.06. So I can use my 180 relationship to find the third angle. And I got 92.9-ish. And then I'm only absent one side. So to find this was, if this was C, then this was A. And I used another law of sines relationship. Sine 35 degrees is to 8 as the sine of 92.93 degrees is to A. Did my cross multiplication, solve for A, and I got 13.93. Now do a double check on yourself, right? Do things make sense? The largest angle in this triangle was what? A, right? This is the 92 one. Is that opposite the largest side? 35 is the smallest. Is it opposite the smallest side? Okay, those things should check out from geometry. Let's go to the obtuse case, right? So this triangle looks like this. There's my 35. Right, so I need to find this angle. But don't forget now, you've got, there's a shortcut to figuring this out, right? Right, if I can do some of my same work. Sine of 35 is to 8. As sine C is to 11. Head scratch, head scratch, head scratch. How am I going to get something different? Isn't this, when I do this on my calculator, aren't I still going to get C is equal to 52.06? But what can what I don't understand. How can this be? Well, look at these angles here. Right? This angle, 52.06, right? If you put this together, angle together, and that angle together, can you see what's happening? I don't actually have to set this relationship up. I'm going to get the same answer. What's the relationship between the size of this angle and the size of this one? Right? I got to get to 180 that way. So that's angle C. How do I get angle A? I better get something small, right? And how am I going to get side A, which also best be smaller than what I had before, right? This is much shorter. I'll go up here to do that. Sine 35 over 11. Sine 127.94 is to A. And when I did that, and of course I could do, whoops, sorry, not 124, sorry, 17.06. And when I cross multiplied and isolated A, I got 4 point, what is that, an O or an 8? I think it's an 8. Which I expected to be shorter than the one I got over here. Whew! Oh my goodness. That was a lot of work. Double check, just like I did before. Right? Where is my largest angle? My largest angle is here. 127 is still opposite the longest side. But now who's my smallest angle? My smallest angle is A now, isn't it? 17-ish. And it is opposite the smallest side. My side of 4 something is smaller than 8. Things check out. This is, right, this is challenging. I know, right? There's a lot of things to consider. This takes practice. The math you're doing isn't hard, right? The computations, it's formulas, subtracting from 180, all that kind of stuff. But it's the setup and knowing what you're going after, right? And it is very easy to feel like a donkey with these problems. Okay. All right. I will see you in our live sessions.